last time we said we will be using the Routh-Hurwitz criterion to check the stability of the system without finding the exact root of the characteristic equation. And if you remember, we said the algorithm, okay, first of all, we check if there is any, term in the polynomial of the characteristic equation is missing or there's a sign change, then we can conclude immediately that the system is unstable. However, if there is no missing term and there is no sign change, we should, formulate the Routh-Hurwitz tabulation. And we dealt with one of the cases, and we have in the tabulation, we said we look into the element of the first column. Okay, if those are positive, if all of them that have the same, if there is no sign change, it means that the system is stable. If there will be a sign change, the number of sign changes will give you the number of roots of the characteristic equation in the right half plane. So any sign change will be, it makes that the system is unstable. We already, took the, we said there are several cases. The first case is that, all the elements in the first column are going to be non-zero. And we already gave an example. Today we will give another example. There will be a case where, let's say, this element is 0 and the other are non-zero. How do we deal with it? A third case, an entire row of zeros. Again, we will, give a procedure. How do we do it? And then finally, if I will have 2 rows of zeros, how do we deal with them? So we will, okay, let's continue in the first case where we have, the element of the first column are non-zero. And let's take another example. Okay, suppose in this example, what do we have? Determine the range of K for which the system is stable. Now, the open loop system, is it stable or unstable?
Open loop.
Unstable.
Or the plant, call it, this is G of S. This is unstable, isn't it?
Yes.
Because we have one of the poles in the right half plane.
Positive. Yes.
So what we want to do, we would like to use Routh-Hurwitz criterion to stabilize this system. So you can think about it, this is a design. I would like to find a range for which K that will stabilize my system by using Routh-Hurwitz. There are other methods of doing it, but let's use Routh-Hurwitz. So the first thing in Routh-Hurwitz, I have to write the characteristic equation. So what's the characteristic equation? What's delta of S equal to?
Yes, we'll have 1 تمام plus G of S.
Exactly. But there is unity feedback, so it's G of S.
ما يحتاج خلاص.
Okay, so basically the delta of S equal to 1 plus K S plus 1 over S, S plus 6, and S minus 1 equal to 0. If we simplify it, this is what we are going to get. Okay, if we simplify it, this is the characteristic equation of the system. Any question here? How do we get it? Just simplify. Cross multiply by the denominator and then collect terms. So now, with this characteristic equation, I would like to formulate the Routh-Hurwitz table. So S cubed, S squared, and those will be, the first 2 elements, the first 2 rows, they will come from the characteristic equation. So what are the coefficients of the first row? what are the elements of the first row?
1
1,
K minus 6
K minus 6, and
that's it.
okay, this is K minus and 0. And in here, what do I have?
5
5,
Why 0 doctor?
1
K, 0. This is just from the characteristic equation. Now I want to calculate the rest, sorry, s to the 1 and s to the 0. In this position,
K minus 6
okay, it's going to be what?
K minus 6
Okay, K minus 6.
and zeros.
No, it's going to be minus 1 over 5, and this determinant 1, 5, K minus 6, and K. This is the determinant, which is equal to minus 1 over 5, okay? This will give me K minus 5K plus 30. Okay, if you simplify it, it's going to be 4K minus 30 over 5. Okay. What about the element in here? This is going to be, again, divide by 5, and then this column and this column. But this column is 0, so I'll have 0 in here.
دكتور مو الفيرست element يكون الكوفيشنت حق الاس.
The first, which one? This one?
ايه.
This one? Yes, it's coefficient of the, yeah, this is the calculation. This is the way I calculate. The first element in here, as I said, is equal minus, sorry, it will be minus, yes, and divide by this element, which is the 5. I don't know, is this your question?
Actually no.
What's your question?
يعني مثلا الاس كيوب الالمنت
Yes.
حقها 1.
Exactly. You come to the, okay, you look into the characteristic equation.
Yes.
You take the, if it is third order, so I'll start third order. I will start by 1. So next to it is going to be 1. And then nothing after that. So I'll stop 1, K minus 6, and 0. I alternate. Then I will have, this is the coefficient of the second order system. So it's a 5, okay? The coefficient of the S square, and then the constant, K. And you proceed in this one.
يس هو سؤالي في الاس تو باور من 1 ليش ما كان الفيرست element يكون K minus 6؟
No, الفيرست element يبني ناخذه من البولينوميال. What is the degree of the polynomial? يعني in general, this is, let's say, an s to the n plus an minus 1 s to the n minus 1, and so on until a1, let's say, s plus a0 equal to 0. We will take whatever the order of the polynomial. The first element is going to be an, then you alternate. This is the procedure. This is the algorithm.
Okay.
Okay. So now if I come back in here, what do I have at this position? You divide by this one. 5 times 0 will be 0. This time this one. Divide by this is going to be just K. Okay. So this is basically what we are going to have. Any question in here? Now, according to the condition, the system will be stable if the elements of the first column, there is no sign change. Since this is positive, this is positive. So when this will be positive, when
K is greater than 8.
no, this one,
Not 8.
K greater than 0, anything positive. And the condition in here, and I need 4k minus 30 over 5 should be greater than 0.
يعني k greater than 7.5.
Exactly. You take the intersection of the two. So in here, k greater than 7.5. Okay? So this is basically what we have.
جميل.
Because if you,
Also we have the negative Dr. part, right?
where?
يعني we can assume that k is less than 0 and 4k minus 3 30 over 5 less than 0 ولا ما يصلح؟
If k is less than 0, so there will be a sign change.
أو يصير في أصلا عندنا 1 و 5 positive we cannot
And
do
to
it.
start with, okay, it's going to be, you know, it will be negative. No, I don't think. No, this is the condition.
تمام.
Condition. It depends on the question. I mean, in this particular question, okay, in this particular example, k is positive. It could be. It depends on the question.
طيب يا دكتور الحين سؤال.
طبعا.
يعني just to broad يعني نوسع السؤال شوية نوسع الفكرة. الحين ما أدري هذه النقطة أنت قبل كذا أشرت لها. لو كان مثلا عندي الكوفيشنتس بدل 5 كانت 0 فكيف أجيب الاس؟ لأنه إحنا اعتمدنا
5
على
equal to 0.
مثلا.
إذا كان look, إذا in the first two, immediately you can conclude that the system is unstable. That's what we say.
أوه جميل جدا.
Okay, immediately. Now the question is in here, and that's what's our next topic.
يا سلام.
Okay, because remember we said in the polynomial, all the coefficients should be there, and there is no sign change. So now suppose I have, if the element, the first element, okay, if I go back, let me go back to the table which I showed you. In this table, suppose you calculate bn minus 1 equal to 0. Okay, and the other are non-zero. How can I proceed to here? We said I have to divide by this element. But if this is 0, how can I divide by 0? So I have to, okay, if this is the case, okay, if this is the case, I will, okay, replace that 0 by an epsilon, a small epsilon, which is a positive number. And then I proceed. Okay. So let's take this example and let's see how do we use it. So this is s to the 5, s to the 4, and those from the characteristic equation. What do I have?
1 2
1 2
1
1 2 6, isn't it?
6 6. Sorry.
0. Then 3
3 6 9.
6 9 0. So I need s to the third. Okay.
جميل.
2
1 over
6
3
0 0.
If is going to be
1 over 3 اسمه
And?
6 minus 6 أو 0 0 في 0.
0. How about the one here?
Here it will be 1 over 6 right multiply by 18 ناقص 12 مظبوط.
Okay. So this is what we have, and this is what we are saying. Sorry, it's 3, not 6.
3
Okay. Now I cannot proceed because of the 0. The next element, a square. If I want to put a square, the coefficient here, basically I have to multiply. I have to divide by the 0. So I will divide now by the epsilon. So let me say this is s squared. Okay. What is the element in here? The element in here is going to be what? It's going to be minus 1 over epsilon. Okay. And then I will have 9 minus 6 epsilon. Do you agree? Or if you put the minus sign inside, it's going to be 1 over epsilon, and I will have 6 epsilon minus 9. Okay, what about this element in here?
الحين يا دكتور انت شلت الابسولوت فاليو ولا ايش سويت هنا؟
لا مش absolute value. This yeah, absolute, well, a determinant.
determinant.
Determinant. This is determinant. So what I say, this is determinant, not absolute.
تمام.
Okay. Now I need this element. This element will be 3 times 0, 9 by epsilon, divide by epsilon. That will give you 9. So this is basically what we have.
مرة ثانية معلش يا دكتور السكند تيرم كيف جبناه؟ شوي بس. ايوه.
This element equal to minus 1 over epsilon, the determinant of 3 times 0, which is 0 minus epsilon by 9. 9 epsilon, which is equal to, let's say, this is not determinant again. Okay, now the minus with the minus will go, the epsilon with the epsilon will go, and you will have 9. Okay?
تمام.
طيب. Now I want to proceed further because I need s to the 1. So what is the element in here? What is this element? Let me first of all, let me clear. So I will use the. So I need now this element. This element will be what? Okay. Epsilon. Okay. 1 over 6 epsilon minus 9 over, sorry, 6 epsilon over epsilon. This is minus, and determinant of, or the multiplication 3 times 3, okay, which is basically 9 minus, okay, sorry, no, sorry, it's going to be epsilon times 9, epsilon times 9, so 9 epsilon. Okay, 9 epsilon minus 3, okay, 6 epsilon minus 9 over epsilon. This is what I.
ابسلون كثير يا دكتور.
كيف؟
اقول في كثير ابسلون صار.
بالضبط. بس it is look simple.
صحيح.
Look, put this one inside. So the first one is going to be minus. The epsilon in here, it will go to, so it's 9 epsilon squared over 6 epsilon minus 9. Minus and minus will be plus 3, but look at this term and the denominator in here. This term and this term, they are the same.
يعني 1.
Only, so it will be 3. So basically 3 minus 9 epsilon squared, 6 epsilon minus 9, and 0. If you calculate this one, okay, if you calculate this one, because this is the 0, okay, so yeah, because of this is 0, this will be minus 9 times this one, divide by this quantity, is going to be only 9.
Yes.
Okay, now let's check if the element in the first column are, you know, greater than 0 or not. Okay, so basically this is positive, this is positive. How about this one?
This is a little bit positive, greater than 0.
Positive, a little bit positive, it's positive.
Yes.
How about this one?
والله will يعني we have to take the limit from the right.
Abdurrahman, take it easy. Don't take the limit. Epsilon is very small number. Take it 0.0001. Multiply by 6.
It's negative.
واضح انها تصير negative.
It's going to be negative because of the 9. It's much higher, much greater than this one. And you are dividing by a positive number. So it's going to be, this is going to be negative. This is negative. How about this one here?
خلاص دكتور ما يحتاج نكمل.
لا.
sign change.
No, wait. If they ask you, I mean, if it's stable or unstable, fine. I agree. But if they want how many poles in the right half plane, you have to continue because number of sign change will give you the number of the roots in the right half plane. Okay? So look at this one. This is going to be, okay.
Positive.
This is, look, this is -9, isn't it? You ignore this portion. So -9 is going to be 9, okay. Let's say a to an epsilon squared, okay. So epsilon is very small number compared to the 3 is going to be, okay. No, sorry, the 9 will go with the 9. Okay, because if you approximate this one, this is going to be -9. -9 and -9 will go, and I have epsilon squared. So 3 minus epsilon squared definitely is going to be positive. And this is positive. So I have, this is what I have. Positive, 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 negative, and positive. Which means that I'm going to have 2 roots of the characteristic equation in the right half plane. Which means that the system is going to be unstable. Any question here? Any question here? So to verify, okay, use MATLAB to verify, give the characteristic equation which we have. Those are the roots, and clearly in here I have 2 in the right half plane. Okay. Well, any question? If there is no question, we'll move. Now, let's have a full row of zeros. The entire row, one of the row, before the last, is going to be 0. So in this case, we will be having roots symmetrically.
كيف الفولو زيرو؟
يعني go back.
يعني كيف
This one, okay. This row, let's say, this, all of them, all the elements zeros.
Oh, all zeros.
All zeros. Not only the first element of the column, no. All of them. This is what we mean. Okay. So in this case, it means that the characteristic equation, it has poles either on the j omega axis or one pole here and one pole here. If this is the situation, then the system is marginally stable, this is unstable. Okay, if we have such a case, okay, we will go to the ith row. If the ith row, sorry, is 0, we form the auxiliary equation, auxiliary polynomial from the row above it, above the 0. Okay, and then I will call that my auxiliary equation. I'll differentiate, okay, the auxiliary equation and use the coefficient to replace the row of zeros. The existence of the auxiliary equation, okay, it is normally, not usually, it is always an even polynomial. That where the symmetry you will have the symmetry, and the auxiliary equation is going to be part of the characteristic equation. This is very important. When we go to root locus, we will be using this property. Okay. Now let's take an example and to show you what do I mean. Okay. Now what is the characteristic equation here? This is the characteristic equation. What are the first two rows of the characteristic equation? Those are the first two rows from the given information. 1, 11, okay, 28, 5, 23, and 12. Any question here? Any question how do we get this point?
ليش ما في zeros يا دكتور في النهاية؟
Well, you put يعني you assume, okay, you have to determine those are the zeros. Definitely, you must have the zeros. Otherwise, you cannot proceed. Okay. Now, we will calculate the next row. The next two rows from the same procedure. We use the same procedure as we did before. Find those elements. Now, what is the next element in here? What's the next element is going to be at this position?
0.
Why 0?
احسبها.
احسبها. يلا.
ايش في؟
So it's basically minus 1 over 3 times 0.4 times 12 minus 3 times 25.6.
انا يقول لي تشيك دكتور first digit عرفت 0 على طول.
Yeah, if you multiply them يعني a relation between.
It has to be 0 because of يعني the example يعني.
No, لا. Do the calculation.
لا, I did the calculation of course.
Yeah,
I mean,
this is 0.
Common sense.
And this, what's here? Look, this is 0, and this is 0. So what's going to be in this position?
Also 0.
Also 0. So basically,
0
0. So s to the 1, s to the 0, 0, 0. So I cannot proceed further. Okay, I cannot proceed further. So what we are saying, let's, okay, go to the row above the zeros and form a polynomial. What is the degree of the polynomial? What is the degree of the polynomial?
First order.
Second order.
Second order. And what's the coefficient of the polynomial?
3 and 12.
3 s square plus, okay, 12 sorry, equal to 0. This is my polynomial. It's an even polynomial.
ليش ما 12s يا دكتور؟
ليش ما يكون ايش؟
12s.
No, you are alternating. If you start in,
صحيح تمام.
okay, because you are alternating. So now take the differentiate. If I differentiate, what do I get?
6s
D
equals 0.
of the polynomial equal to 0. So this basically is going to be 6s plus 0. So I will replace this one by 6 and this is going to be again 0. It doesn't matter. So if this is 6 and this is 0, what do I have in here? I have 12.
عجيب يعني this is kind of remedy يعني يا دكتور ها؟
Exactly. Well, look, those guys, they work, this research, okay? They work, okay? So now, let's apply the theory. So, in here, there is no sign change. Does that mean the system is stable? Yes. Look like. However, because of the auxiliary equation, okay, What are the roots of the auxiliary equation? The roots of the auxiliary equation, u of s, we said, if you set this equal to 0, so we'll have s equal to what? Plus or minus j2, isn't it? It means that my system has two poles, one here and one here. And because this is part of the characteristic equation, okay, so it means that I have in my characteristic equation, I have two poles on the j omega axis, which means that my system will be oscillatory type or marginally stable. Okay. If you use MATLAB, this is basically what you are going to get. By the way, okay, if I can, even without MATLAB, I can find the other three poles. Basically, if you want to find the other three poles, you divide the characteristic equation by the auxiliary equation by, let's say, 3s squared plus 12, or by s squared plus 4, because this is part of the characteristic equation, and that will give you a third order system, which give you the other roots of the system. Sometimes you will be asked to find where is the location of the other poles of the system. Any question before we wait? Well, I think no. Let's stop in here, because the exam, I want you to just go to the quiz. Prepare yourself. Go to the Blackboard. The quiz will be again in the section of quizzes, and it's going to be S4. Sorry, Q4S2. Okay. And let me go to the here.